Okay, welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 6 from the June 2012 International, well, it's actually the old GCE Edexcel Mechanics M1, the 6677 specification. The mechanics specification hasn't really changed at all since the old and the new syllabus, which started in 2018. So these questions from the previous years are perfectly good to revise from. So I've been requested to answer this question number 6. It says a ship is moving with the constant velocity of the ship S which is given by minus 12I plus 7.5J kilometers per hour. Find the direction in which S is moving, giving your answer as a bearing. So it's going with a velocity of minus 12I and plus 7.5J. Now the velocity vector tells us two things. It tells us the direction and its speed. The direction is going in and its speed, and the magnitude of this velocity would give us the speed, and the direction is given by the components of the vector. So let's just say it's here at that particular point. That means in 1 hour it's going to go 12 units to the left, which is west in this case, and 7.5 units north. So this is how its components would look. The component vectors would look for this. It would be 12 to this side and 7.5 up. So I've just, not really to scale, but I've just drawn something there. So the vector, the direction it would be going would be along this particular line over here. That's how it would look. So that's the direction of the ship S. This direction is 12 units to the left, to the west you could say, and 7.5 units up to the north. So we want to find this direction as a bearing. So it starts from this point over here. Okay, so I'm going to draw a north line at this point over here because that's where it's starting from. So this is the north line. Okay, so bearings are always measured from the north line, and they're always measured in the clockwise direction. So we're looking for the angle over here. Right, there's a number of ways we could find this. We could say, okay, if I know this angle inside, which I'll call theta, then what we're looking for is 360 minus theta. So this angle, I can find it by knowing that it's the same as this angle, because these are alternate angles, because this is north, remember this was west and north, so these are parallel lines, so these are alternate angles, so this is also theta, and I can find this theta because this is, as I said, north and west, so therefore this is going to be a right angle. So we can say that the tangent of the angle theta is equal to the opposite, which is 12 divided by the adjacent, which is 7.5. So we can say theta is equal to inverse tan of 12 over 7.5. So that will be the value of theta. So we do inverse tan of 12 divided by 7.5, 12 divided by 7.5. Close that bracket. Now we must make sure we're in degrees because bearings are measured in degrees. So that's going to give us 57.995 degrees. So theta is 57.995 degrees. That's not the bearing, however. We're looking for the bearing, and we know that the bearing that we're looking for, the bearing is going to be 360 minus 57.995. So we take our answer and we subtract it from 360. So 360, take away our last answer. That gives us 302.005, 302.005 degrees. So therefore, we know that the bearings are measured to the nearest degree. So that's 302 degrees. There's the answer for part A. Okay. Then it says, at time t hours after noon, the position vector of S is given by the vector S kilometers. That tells us its position with respect to the origin. When time equals 0, S equals 40I minus 6J. Write down S in terms of T. Okay, so that's what we have to do next.